So, we're going to start section 5 by posing a question to you. So let's put another question up here.
That one hurt.
Two dice are rolled. How many ways can the dice come up with no ones? So does the question make sense?
Can you put it up on the board?
Oh, yeah. I thought you were getting that. Make more sense if you could see it, probably.
Did you say how those side dice? We're talking a 20-sided, 10-sided, 4-sided?
6-sided. Your regular 6-sided dice, like you're playing Yahtzee here. Okay? So you put 2 dice in the Yahtzee cup and go and make that obnoxiously loud noise that it makes, and then throw it out onto the table and hope one of the die don't roll into the floor like we've all done, right? Of course, if you roll it into the box, that helps. But the question is, if you roll 2 of them, how many ways can they come up where neither one of them is a 1? That's what I'm asking.
So you can have 2 and a 2, so repetition does matter.
Well, let's think about different strategies we could use here. It's not the question of does repetition matter, it's the question of is repetition allowed? Okay, so let me ask you, class, is repetition allowed?
Yes.
Yeah, because I could get snake eyes, right? Or you get 2-2 or 3-3. So repetition is allowed. So if we go that route, we're probably going to be drawing blanks. And in a moment, we'll go that route. Okay? Another thing we could do is just list them out, all the ways we could roll them without getting a 1. So I'm going to do that really quick. Okay? Let's see. I could get a 2-2, 2-3, 2-4, 2-5, 2-6. Or 3 on the first, 2 on the second, 3-3, 3-4, 3-5, 3-6. Or I could get 4 on the first, 2 on the second, 4-3, 4-4, 4-5, 4-6. Or 5-2, 3, 4, 5, 6. Or 6-2, 3, 4, 5, 6. Am I missing anything here? Is that all of them? Yeah, the only thing I left out were all the rows where I'd get a 1. And so that leaves all the others. And what have I got here? 5 rows of 5, 25 different ways it could happen. Now, I call that coming in the front door. We just counted all the different ways we could not get a 1. Okay? Here's another approach we could have taken on this problem. And on this particular problem, this approach probably, to be honest with you, wouldn't be any easier. But on some problems it is. So let's start with this problem and then we'll get to those problems. Okay? What if I thought this way? What if I took a James approach? He started thinking, is repetition allowed? We established that it is. So we could draw blanks, and we're rolling 2 dice. How many ways could the first die come up?
5.
Well, don't think about the ones yet. Let's think about all the different ways that the dice could come up. 6 ways the first one come up. How many ways could the second one come up?
6 ways.
6 ways. Okay, so there's 36 different possibilities total, right? When I roll 2 dice. Now what I could do is I could take out all the ones that have a 1, and that would leave me all the ones that don't have a 1, right? Follow that? If I take all 36 ways the dice can come up, and then subtract out all the pairs that would have a 1 somewhere, if I take those out, that leaves me everything else. All the ones that don't have a 1. Yeah, there's 11 ways of 1. What are all the ways I could get a 1? Well, I could get a 1-1, a 1-2, a 1-3, a 1-4, a 1-5, or a 1-6. So there's 6 ways. But here, if I rolled a 2 first, I could have got a 1 second, that's 7. 3 first, 1 second, 8. 4, 1, 9. 5, 1, 10. 6, 1 is 11. So do you see that there's 11 ways I can get a 1? So how many ways could I not get a 1? The 36 total minus the 11 ways that I could get a 1 leaves me 25 ways that I wouldn't get a 1. Now, if you would have taken an approach like that, you would be using something called the complements rule. Okay, so let me tell you about the complements rule. You've been using the complements rule ever since you were in about 2nd or 3rd grade. Your teacher would give you a problem like this. She, most likely, most elementary teachers are female, right? She would say, there are 10 pieces of fruit in this box. 4 of them are apples. How many are not apples? Well, you take 10 minus 4 and get 6, right? So what do we say? The number that are not apples equals the total minus the number that are apples, right? Now, being an apple and not apple, those are called complements. So the complement of an event is everything else that can happen besides the event. Everything else that can happen besides being an apple is not being an apple. Right? Like being an orange or a fruit or a grape or something else. When I flip a coin, the complement of getting a head is getting a tail, because that's everything else that can happen. When I roll a die, see my die I'm getting ready to roll? What's the complement of rolling a 2? There you go, rolling a 1, a 3, a 4, a 5, or a 6. It's everything else that can happen, right? The complement of rain is not rain. The complement of me jumping is me staying on the ground, okay? It's everything else that can happen, okay? So, what the complements rule says is N of E, that stands for the number of ways an event can happen, is equal to the total number of possibilities minus the number of ways E would not happen, which we call E with the superscript of C for the complement of E. So the number of ways an event can occur is equal to the total number of possibilities minus the number of ways the event's complement can occur. The number of ways of not getting a 1 is equal to the total possibilities minus the number of ways I can get a 1, because getting a 1 and not getting a 1 are complements. So sometimes it's easier to figure a problem straight on. Sometimes it's easier to use the complements rule, which I call coming in the back door. If I say, let me get my marker the right color here that I want. How many cards are not kings? Well, I have two options. I can either count all the cards that are not kings, or I can take the total minus the number of cards that are kings. That seems to be easier here to me. The number of the complement of kings is equal to the total minus the number of kings. What did we say the total number of cards was? 52. What's the number of kings? What's the number that aren't kings? 48. Ball game. Game, set, match. Okay, so I have a question for you. Yeah, the complement of king would be not being a king. So, yes. Now, let's say we go down to the gym right now. I'm going to show you a specific type of problem where this is a very helpful tool. Okay, so let's go down to the gym and let's say I'm going to shoot free throws. And let's say I'm going to shoot 5. Holden, how many do you think I'd make out of 5? 3? You think I'm a 60% free throw shooter? Wow, Holden, that's not very much confidence. Linnea, how many do you think I'd make out of 5?
1.
Wow. 1. Okay, Linnea, I want you to watch this, okay? Here's 2 dribbles. I'm setting, I'm shooting, hands in the cookie jar, okay? That's my form. 2 dribbles, set, hand in the cookie jar. Now how many are you giving me?
0.
What'd you make? You get 3.
I get 2 now? Okay, I'll take it. Okay, so what I'm interested in
Hold on.
is what if I was talking about at least me making at least 1 free throw? At least 1.
That's what she said. 1.
So my question to you and what I want you to think about is, what would the complement of at least 1 be? In other words, what's everything else that can happen besides at least 1? Now, if I make 1, is that at least 1? Yeah. If I make 2, is that at least 1? What about 3? Or 4? Or 5? Class, what's the only way that I couldn't make at least 1 free throw? Is if I make 0. Okay, what I want you to take from this is the complement of at least 1 is 0. Okay, so if I'm asked for how many ways can I get at least 1, or the number of at least 1, like I have on the screen here, since the complement of that is 0, then what I can do is take the total number of things that can happen minus the number of ways that I could make 0. If you get an at least 1 problem on your test or in your homework, this is what we're going to go to. Okay, we're going to go to the complements rule, and we're going to apply this right here, and it'll be far easier than figuring the number directly. Let me illustrate. Let's go to example number 2. That example is on page 568. Now, look at me a minute before you read that problem. Listen, what we want to do moving forward is get the big picture idea and then worry about the nuts and bolts of a problem. So we're not always going to know every single step we're going to take at the start of a problem. All we're trying to do is get a big picture idea about what we want to do, and then we can get through the specifics as we move along. So, with that in mind, example 2 says, if 4 fair coins are tossed, in how many ways can at least one tail be obtained? So this is an at least one problem. We're looking for the number of ways I can get at least one tail. So what's the big picture idea on this problem? I'm going to take the total number of things that can happen minus the number of ways I can get 0 tails. So that's how I want to start. I'm not trying to do anything more than just that right now. Get the big picture in place. Okay, so now I've really turned this into 2 problems. I got to get the total number of things that can happen and subtract from that the number of ways I could get 0 tails. So let's worry about the total first. Okay, so what am I doing? I'm flipping 4 coins, right? Is repetition allowed?
Yes.
Yes, it is. So what am I doing?
Blanks.
How many blanks?
2.
How many parts are there to this problem? 4. I'm tossing 4 coins. So there's 4 parts. What can happen? How many different things can happen on the first coin? 2. And how many on the second?
2.
And 2 and 2. So if I toss 4 coins, 2 times 2 is 4, times 2 is 8, times 2 is 16. There's 16 different things that can happen if I toss 4 coins. 16. Minus. Now let's work the second part of the problem. How many of those 16 things would have 0 tails? You're saying half of them would have 0 tails? What would have to happen for me to get 0 tails if I flip 4 coins?
All heads.
I'd have to get all heads. How many ways can I get all heads?
16.
16.
No. 1. There's only one way for me to get all heads, and that's if I get head on the first, head on the second, head on the third, and head on the fourth. Right? What other way is there? That's it, right? So there's one way I can get 0 tails. That's it. So how many ways can I get at least 1 tail? 16 minus 1 is 15. Now, if I didn't use the complements rule there, what I'd have to do is figure out all the ways I could get 1 head, all the ways I could get 2 heads, all the ways I could get 3 heads, and all the ways I could get 4 heads, and then add all those together. So that'd be 4 different problems, and it'd take me quite a while. But if I just think about how many ways can I get 0 heads, that's 1 problem. And it only happens 1 way. And so it's a lot quicker to figure that one coming through the back door. So if you get an at least one problem, that's what you're going to, that formula. Take the total minus the number of ways you can get 0. And usually the number of ways you can get 0, usually that's going to be 1. Okay, questions, thoughts, or feelings here, class? Okay, I'm pausing my. What if I posed this question to you? How many of you like, and I got to think of a couple different dishes here. I'd like something that some people like, but some people don't.
Curry.
What is that? You mean like the spice?
Yeah, curry plates. You know, the curry sauce.
Okay, let's do a specific dish. I think it'll be easier.
Fried chicken.
Everybody likes pizza and everybody likes fried chicken, so I don't want to use those. I'm looking. I was thinking of spaghetti myself. Although I hope not everybody likes spaghetti. That'll make this easier. How many like spaghetti or here's something not everybody's gonna like. Did I spell that right? How do you spell broccoli?
I love broccoli too. I love all food.
Let's see if that's right. How many of you like spaghetti or broccoli? That's my question. I don't know if I spelled broccoli right or not. We're gonna pretend.
I like haggis.
And I'm talking about the people in our class right now. So there's what, 3, 5. Let me turn the camera on our students here. It's 8. There's 11 of us here today. 11.
I like both, I guess.
So,
But Orr is asking one or the other.
well, let's talk about that, James, for a minute. If I say that you like spaghetti or broccoli, if you like spaghetti, do you get included?
Yes.
Yes. If you like broccoli, do you get included?
Yes.
If you like spaghetti and broccoli, do you get included?
Not necessarily.
So you're telling me that if someone, I do like both of them. So if they ask me the question, how many, David, do you like spaghetti or broccoli? You're telling me I should answer no. Is that what you're saying?
Yeah,
I do like
you,
it.
you like both, so you should say yes, but whoever doesn't.
Well, it's an or question.
That's right. And my contention is, or means spaghetti or broccoli or both. The only way you wouldn't like one or the other is if you didn't like either, right? The only way you're going to answer no to do you like spaghetti or broccoli is if you don't like either one of them, right? Okay, so let's do this. Now I'm going to keep me out of it. We're just going to do the students. How many of you like spaghetti? Get your hands high here. 1, 2, 3, 4, 5, 6, 7, 8. That's all of you. See, I knew spaghetti wasn't going to work. I don't want it to be all of you. Let's pretend. I want something real here. So let's go.
Fried chicken livers.
Cauliflower.
You don't like cauliflower? It's not a word.
How many of you like cauliflower or broccoli? Let's do that. How many of you like cauliflower? Raise your hand. 1, 2, 3, 4, 5, 6, 7. I see 7 hands. 7 of you like cauliflower. 7. How many of you like broccoli? Get them high now. I didn't say to get high. I said get your hand high. 3 in Anna. 2 in Metros, 5. 2 in Cairo is 7. And 3 here is 10. 10 of you like broccoli. Now, here's my question to you. How are you going to take that information and figure out how many of you like either cauliflower or broccoli? Do you know what a lot of people would say? They would say add 7 and 10 and get 17. That cannot possibly be right because there's only 11 of you, right? Well, that's not the answer. What mistake did I make when I put 17?
Repetitive. You repeated it.
What did I repeat?
The persons that you were counting.
Which persons?
The students.
Which students? What, Donna?
Like you counted me twice for both cauliflower and broccoli.
And what did you say, Donna?
The people that like it, like the broccoli, like
Okay. The mistake I made was I counted the people who like cauliflower and broccoli both times. You see that? So if you liked cauliflower and broccoli, I counted you in these 7. If you like cauliflower and broccoli, I also counted you in these 10. So some of you were double counted. See that? Now how many of you raised your hand both times? Okay, 2 here, 3, 4 in Anna, 5, 6, 7. 7 of you did. So I double counted to the tune of 7. So if I take that 7 back out, the answer's 10. Okay, which means all of you like either cauliflower or broccoli or both. There's only one of you who didn't raise your hand either time. Who didn't raise their hand either time? It was Dustin. See that? Does that make sense to you? Now, what am I getting at here? I'm getting at how we're going to do a problem that says or. And I just call these or problems. So if I get a question that says how many with or, how do I do that? So I don't remember what letter we're on here, so I'm just going to forget that part. So I'm going to put here or problems. And what we're going to do is we're going to use a formula. So every time we get an or problem, we're going straight to this formula. We're not going to try to think too much on our own. Just go to the formula. It'll save you problems. So the number of A or B, that's like saying the number of cauliflower or broccoli. Let's think about what we did up here. We took 7 plus 10 minus 7. This 7 was the number that liked cauliflower. So the first thing we're going to do down here is take the number of the first, number of A, plus this 10 right here was the number that liked broccoli. So the number of the second, number of B, minus, what was this 7 here? The number of both. That's right. So the last thing we're going to do is subtract out the number that like A and B. So anytime this chapter we get an or problem, we're going to go straight to this formula and we're going to plug into it. Okay, so with that in mind, let's do some card problems. Let's say I'm going to draw 2 cards from a standard 52 card deck. That's wrong. Let's say we're going to draw 1 card from a standard 52 card deck. And let's say the question says this: how many ways can a red card or the 5 of spades be chosen? Let me try something here. Oh, there we go. I can make it bigger. Should have done that earlier, huh? Okay. Are we ready? Am I getting out in front of you? We ready to move here? So here's the first thing I'm going to do now. I'm going to recognize that this is an OR problem. Bless you. If it's an OR problem, I'm going to use an OR formula. So I'm looking for the number of ways of getting a red or the 5 of spades. So how's that OR formula work? It's the number of the first, number of red, plus the number of the second, the number of 5 of spades, minus the number that are both red and 5 of spades. So, Amy and Dustin, in a 52 card deck, how many are red?
26.
James, I did not ask you. I asked Amy and Dustin. Even though you're right, it is 26.
That was Dustin.
That was Dustin.
No, I heard somebody whisper.
We heard y'all.
Yeah, oh yeah, we're on. That's right. These ears, they're good. They're good ears. 26. See, it's not hard to hear when people whisper. And that's with the microphone, probably about 10 feet from me. You can hear me just sneaking fine because these microphones are good. That's right. Hey, James, how many 5 of spades are there?
1.
That's correct. I heard that whisper too. That's right. I heard it. Minus, class, how many cards are both red and the 5 of spades? None are. The 5 of spades is black, right? It's a spade. So 0. By the way, if this number ends up being 0, then your two events, in this case red and 5 of spades, are said to be disjoint, or sometimes you hear the term mutually exclusive. Okay, so the answer to this question is 27. Now, let's change the question. Let's say, instead of saying how many ways can a red card or the 5 of spades be chosen, let's say how many ways can a red card or a king be chosen. Red card or a king. Again, the big picture idea here is, oops, I didn't mean to scratch out or. The big picture idea is that it's an or problem. So we'll go to the or formula. The number of red or king equals, okay, what's my formula going to look like, class? What? Number of plus minus, very good. I don't know. Not there yet. Not that fast. You're faster than me, Daniel. You're very fast. Okay, Holden and Shamari. Well, we just answered this. How many red cards are there? There are 26. So how many kings are there? There are 4. Minus. Class, how many cards are both red and king? 2. What are they? King of hearts and king of diamonds. So red and king are not disjoint. Red and 5 of spades is disjoint. Red and kings are not disjoint. So this ends up being what? 28 cards? 28 different ways that you could get a red or a king. Okay, questions, class, about OR problems. Okay, so today, yes, did somebody say my name?
Yeah, on the first one, before you changed it to king,
Uh-huh.
so you said since the number that contains both of them 0, then it's the disjoint.
Yes.
Okay.
Also known as mutually exclusive.
Okay.
If you're an Illinoisan and an Union Countyan, that's not disjoint because you can be both at the same time. But being an Illinoisan and being a Missourian, those are disjoint because you can't be both at the same time. Disjoint or mutually exclusive means you can't be both things at the same time. Okay, here's your assignment. So section 3 is a big one, section 5 is a big one, section 4 is a little one. So from this section, I think 3 and 6 and 13 through 15 and 27 through 32 will give you the practice that you will need. Now, as we move on into chapter 11 tomorrow, we'll also back up from time to time and look at problems from chapter 10 so that we kind of keep this all fresh in our minds and separate it out in our minds. Now, Metro, Anna, Cairo, I'm going to let you guys go because I want to hand out the test back to the students here. So I hope you have a nice evening and I'll see you tomorrow.